Good morning, everybody. So today we are going to be looking at limits. This is basically an introduction to calculus, and this is still pre-calc in a way. So this is what we have for the time being. When we say the word limit, we're looking at what happens to the graph, the y value, as x gets closer and closer to that value. So let's see, let me go ahead and write this out for a little bit just so that you can see what I'm talking about. So the terminology of the limits you will see as the following. Limit as x approaches towards a number of a function f of x is equal to L. So let's go ahead and define that as we said. So first we have, oh, that is nasty. So let me go ahead and erase this here. Let's go ahead and draw a graph, and here's x, here's y. So suppose that you have a graph, we'll go ahead and call f of x right here. I want to find out what happens with the graph as x gets closer and closer to a certain value a. So for example, in this case, I'm saying that limit as x approaches towards a. So let's say that x is equal to a is over here. Now, for the function f of x, that's going to be this curve over here. The L value is then going to be graphically over here at this point. That's going to be our y value then. So as you can see for the graph, as x is approaching towards a, you can see that it's getting closer and closer to the y value of L on the right hand side, and also as x approaches towards a from the left, it's also getting closer and closer to that value of L on the left hand side. Now, does it mean that you can actually just plug things in because it looks very trivial for the most part? The answer is no, unfortunately. So we're going to go ahead and look at some examples of that. So here, what I have is a graph, and the function is unknown, and we don't really care too much about the function itself. But what I would like to do is solve for the following limit problems according to what we have. So above, you can see the graph. We'll go ahead and call that f of x. And the bottom, here are some of these limits problems that I would like to solve for. So for the first one over here, and let me go ahead and get my pen ready once again. I want to look at what happens. Sorry, just a little playing around. See if I can get used to it. What is wrong with this pen? Let's see. Oh, sorry, a little technical difficulty here. Okay. Oh, I can draw on top, but I can't draw on the bottom. That is strange. So let me see if I can change that a little bit. Okay, so again, what I would like to solve for is the first one right here, which says the limit as x approaches towards 1 of the function f of x. Now, let me go ahead and pull up the other graph where f is supposed to be, which is over here. I would like to know what happens as x gets closer and closer to 1 graphically. What is the y value that it's getting closer to? So you can see that coming from the left, and that means it's getting closer and closer this way. Coming from the right, it's getting closer and closer this way. So one would say that as limit as x approaches towards 1 for f of x, the value that you get, the y value, is going to be equal to 4, because that's where the y value is over here. So that will then be our answer for the first piece, and that's going to be our answer then. So it looks pretty straightforward for the most part. Now let's go ahead and look at number 2, this time where I'm looking at the limit as x approaches towards -2 of this function. So we go back over here. You can see the graph at x equals to -2. Now, some people might think, oh, well, the answer has to be equal to 2 because, well, that's what you get when you plug it in. But remember, when I say limit, I'm looking at what's happening graphically. So that means it's not the same thing as plugging it in, or it's not always going to be the same thing as plugging in. On the graph, as x approaches towards -2, coming from the left-hand side, you can see that it's getting closer to the value of 3 on the left. Coming from the right-hand side, you can see that it's getting closer also to the 3 because they are both heading towards that removable discontinuity. So then that means that the limit as x equals to -2 is actually going to be equal to -3 because that's where the removable discontinuity is located at. Okay. Again, keep in mind that the limit as x approaches towards a of f of x does not always equal to f of a. Okay, not always true. Now, let's look at number 3 over here then. This time, limit as x approaches towards 3 of f of x then. So again, we go back to this graph, and you can see now this is a conflict because, again, when we look at limit, we look at what happens graphically. Well, graphically, I can come from the left-hand side going towards 3, or I can go from the right-hand side going towards 3. From the left-hand side, you can see that it's going towards 0, this removal of this continuity. But from the right-hand side, it's going towards -4 because it's going towards, graphically, it's coming from this line over here on the bottom, on the right-hand side. But graphically, it's coming from this curve on the left-hand side on the side. So because that there is a discrepancy, the limit from the left and the limit from the right do not agree, then we say that the limit actually does not exist. So going back over here, we say that this is going to be does not exist, DNE for does not exist. So does not exist. Okay, and the reason again is because limit as x approaches towards 3 from the left-hand side, and this little negative sign means that it's coming from the left of the function, is equal to, looking at the graph again, is equal to 0. So that's going to be this, whereas the limit as x approaches towards 3 from the right-hand side, and that positive means that's coming from the right-hand side of f of x, is equal to, going to the graph over here, you can see that it's going to be -4. So then that means that this is equal to -4. And these two right here, they have to agree with each other because the limit coming from the left has to be the same as the limit coming from the right in order for the limit to exist. So these two are a contradiction to each other, so therefore the limit does not exist then. So that is actually a pretty key thing that we need to keep in mind. And in fact, let me go ahead and write that right now. The limit as x approaches towards a from the left of f of x has to be equal to the limit as x approaches towards a from the right of f of x has to be equal to the limit as x approaches towards a of f of x in order for the limit to exist. So this we can actually kind of treat as a theorem then from here on out. Okay, so that was kind of the more difficult part. Now let's look at something a little bit more easier. So let's say this time I give you the limit, I give you the function, and I want you to find the limit. Well, for the most part, it would be nice if we could just go ahead and plug things in, and that's what we would ideally like to do. So number 4, here's an example where we actually can do that. X squared plus 1, we know that that is a continuous function. So let me go ahead and write that out. Continuous function. And what by continuous function, I basically mean that you can plug in any value of x and this equation would be fine. And that is to say, there's no restriction for the domain. Y is always going to be defined because x is always going to be defined. And anytime you have a continuous function, you can always just go ahead and plug in the x value. So plugging in 5 into the equation, we are going to get 5 squared plus 1 is equal to 26. So that right there is going to be our limit then. Now, remember earlier, we did say that this right here is not always true. And this is a case where this is going to be true. And the reason why it's true, again, is that f of x is continuous. So long as f of x is continuous, we can always do that. For number 5 over here, though, let's see what happens. When we try to plug in x equals to 2, there's a problem because plugging it in, you can see that you get 2 squared minus 4 divided by 2 minus 2, which is going to give you 0 over 0. So that is a problem. And in fact, if we look at our equation, x can't equal to 2 because we can't just literally plug it in since the denominator would give us 0. So if we can't plug in x is equal to 2 directly, then that means that we might need to kind of like play around with it a little bit algebraically or maybe look at it graphically. Now, if you remember going back to your Algebra 2 days, and let me go ahead and erase this for right now, this can be simplified a little bit because the top part is going to be factorable. And let me just go ahead and erase this one more time. So let me go ahead and rewrite this. I'm going to write this now as limit as x approaches towards 2. The top factors according to difference of square, x minus 2 multiplied by x plus 2, all divided by x minus 2. And that's nice because look, now these two factors are going to cancel. And what we have now is limit as x approaches towards 2 of just x plus 2. we get something that is going to be continuous, which we can plug in. So the answer is going to be 2 plus 2, which is equal to 4. So in essence, what that means is if you cannot plug in the value of x that you're trying to find a limit for, try to do something algebraically and see if that will work out nicely then. The next one over here for number 6, I want to know what the limit is as x approaches 0 for the graph of square root of x. And this right here, this is actually a trick question. And let me just go ahead and write that in right now. Trick question. Okay. The reason why this is a trick question is, well, let's look at the graph of y is equal to square root of x. Here is kind of like a rough sketch as to what it looks like. Y is equal to square root of x, and let me go ahead and put that over here. Going back to what we said earlier, this fundamental key part right here. The limit from the left has to be the same as the limit from the right in order for the limit to exist. If you look at our graph right here for y is equal to square root of x, yes, I can go to x is equal to 0 coming from the right-hand side because it's getting closer and closer to 0. But coming from the left-hand side, well, that's a problem because I don't actually have a graph. So in this case, what's happening is when I try to solve for the limit from the left as it is coming from the right, limit as x approaches towards 0 from the left of square root of x, the answer does not exist because there's no graph. Limit as x approaches towards 0 from the right-hand side, well, that limit exists because it's going towards 0. Well, because these two right here are not the same, there's a contradiction. So that means that the limit for number 6 right here is also does not exist then. Okay, so you got to be careful for these type of things. Okay. Now, the last 3 problems right here, number 7, 8, and 9, those you actually cannot solve for the time being. So what that means is if at any time you cannot just plug in, or you can use a factoring technique or an algebra technique to simplify, we're going to have to use a calculator to actually solve for this. So number 7, we have the limit as x approaches towards 0 for sine of x over x. Let me show you what the graph actually looks like, so then that way you can see what's happening. So this is our graph right there. You can see the equation, sine of x divided by x. So graphically, you can see that they're both going towards something. Now let me push this trace button so you can see what's happening. From the left-hand side, it's getting closer and closer to something. And on the right-hand side, it's getting closer and closer to that same something. Now, if you want to figure out what that something is, you can probably see the y value, which looks like it's getting closer and closer to 1. But if you can't quite do that, well, maybe we can kind of plug it in just to see what happens then. So here's what I mean. Let's go ahead and plug in the following. Let's say sine of 0.01, okay, divided by 0.01, because I wanted to plug in the value of x as it's closer and closer to 0. Oh, and by the way, that right there is a problem, because if I try to plug in 0 into my equation right here, you're going to get 0 over 0. And that's why this plugging in method doesn't actually work. So that's why we have to look at it from a different approach. So nonetheless, let's go back to what we're saying on the calculator. I am going to go ahead and plug in values of x that's closer and closer to 0 to see where it's going towards. So for example, sine of 0.1 and then divided by 0.1, right? So you can see that that's the y value that's close to. Now let's get it even closer. Sine of 0.01 divided by 0.01. So there is a pretty accurate estimate. And then let's do it one more time. Sine of 0.001 divided by 0.001. So each time, what's happening is the y value is getting closer and closer to something, and that something looks pretty close to 1. So I'm guessing that's going to be my limit. Well, that's from the right-hand side. Let's just verify that's the same thing from the left-hand side. So sine of negative 0.01 divided by negative 0.01. Okay, and then we have sine of negative 0.001 divided by negative 0.001. So you can see that from the left-hand side, we are getting the same value, or the y value is approaching towards the same thing. So from that conclusion, we can then say that the limit is going to be equal to 1 then. And let me go ahead and use a pen so you can actually see it. Okay, so you have to use a calculator. Okay, have to use a calculator. Okay. Okay. For number 8, we can do exactly the same thing. Plug into the calculator just to see exactly what's happening. If you can look at it graphically, that'll be great. So let's go ahead and do that and see what happens then. So here is my graphing calculator once again. My equation is 1 minus the cosine of x, and then, oops, sorry, let's see, we don't want that 9 there, and then, let's see, we divide, and then put in the parentheses, and then all divided by x. Okay, so here's the graph. Okay, you can probably pick it out from here, see what's happening graphically. From the left-hand side, the y value is getting closer and closer to, let's say, looks like the origin. And from the right-hand side, graphically, it looks like it's getting closer and closer to the origin. And again, if you're not sure, you can go ahead and plug in the values of x into your calculator just to see. But looking at the graphing calculator, I think that is pretty good conclusion that we can get. So that means that this is going to be equal to 0. And last one over here, limit as x approaches towards, now this one's a little bit tricky. We're going towards infinity for cosine of x. Here, the reason why that's tricky is, well, let me just go ahead and draw cosine for you over here on the bottom. Cosine is going to be something like this, right, as a graph. And you have to excuse my graph because it does look kind of nasty. I want to know what happens as x goes towards infinity. What is the y value that it's going to? Well, this is a ambiguous case because the y value that you get, well, there's really no ending. It's always going to oscillate somewhere between 1 and -1. So because you don't know where that oscillation is going to end, if it ever ends, then that means the limit actually does not exist, because the limit has to be a finite number, has to be a certain numerical value. It can't be 2 values, or it can be 5 values like that. So the answer for this one is also does not exist. Okay, so that concludes our basic introduction to limits. Thank you for watching. I will see you next time.